All right. Good afternoon or good evening. Good evening. I don't know when you're watching this. Um, I just want to say a few things before I start the video, like the auto cycle stuff that I want to say. I'm sorry for not going to class today. It was I should have posted an announcement, but I didn't find out that I wouldn't be able to go until late this morning. So I I apologize. I tend to tell you, like at least with an announcement or an email, or I try to record. But this time it was different. So I'm sorry. I appreciate your messages and your concern. Everything's all right. You may think it's kind of unfair that she's sending us videos if she missed class, but we started the auto cycle on Wednesday, and if we wait till next Wednesday, we're gonna forget every. Sorry, we're gonna forget everything we talked about. I might even forget what I talked about. I just want to know where I stopped or something. So I just want to give you the opportunity to stay on track. So if you feel very comfortable with everything we've done in class, like isentropic processes and constant volume and work and everything, then you know that we reviewed not we studied all these equations before, so um, it's you might be fine if you don't watch this. When we come back on Wednesday of next week, I'm going to review the auto cycle for about 30 minutes and go over an example that I'm going to go over it now on two videos that I'm posting on YouTube, but I'll do it again on Wednesday, at least just a little bit, not a lot of detail, just in case you feel like it's unfair that I'm sending you this. But the video will have more detail, like where does this come from and why does it have this behavior and how do I find that efficiency and so on. So you'll benefit from watching this. So again, when we come back on Wednesday of next week, I'll start with the auto cycle for maybe 20-30 minutes, and then I will post practice problems before then for the auto cycle. So you may practice after watching these videos, or you can wait till Wednesday and do that as well. Your exam is only until the auto cycle, so it's on isentropic processes for ideal gases and change of entropy for ideal gases. We only discuss air. So I'll post a study guide before before that before Friday, actually before Wednesday, and then the auto cycle. So that's it. So there will be no diesel cycle. So that's the only advantage, I guess, or one of the advantages of me not going to class today. The diesel cycle is not complicated. It's actually pretty similar to the auto cycle, but you know, I think it works out. So your exam, it won't have a tricky problem either. In the past, I've thought you guys benefit from solving these questions that might be conceptually challenging, but I think you've reached a point now, and I don't want to cry or anything, but I think you've reached a point where you get it. Now you get it. So you get these values for Q or for temperature on your take home, and you were wondering, oh, maybe this is not right because this is so high, and now you get it. So there's no point in me giving you this tricky problem. So it's gonna be pretty straightforward. For the auto cycle, just be like, this is the minimum and the maximum volume, and it starts 25 degrees Celsius in 1 bar. So what do I get out of it? It's something pretty straightforward. So it's you would benefit a lot from understanding everything we've covered so far, because if you understood it before, because now it's just putting a lot of it together for closed systems and for ideal gases. So yeah, before Friday, I will have that study guide for you and some practice problems for the auto cycle that you may start on Wednesday if you prefer. And I will also have a lot of office hours on Thursday, right before your short exam on Friday. Okay, so that's a good 5 minutes of small talk, I guess. So sorry. So now we're gonna start this, and I am attaching my notes. Let's see, this is better. Yeah. So I'm gonna attach this to the email, so you can follow the notes. Okay. So as I talk, I'll be following this since I don't have a board. Should get a board and just write there, but I don't have one. Okay. So the Otto cycle, we know that it models what's happening inside an internal combustion engine, and we made certain assumptions, the air standard assumptions, and we talked about that last time. We said that all the processes are internally reversible. Internally means your system. That means that Sgen is 0 for all of them. Then we said that the only working substance is air and it behaves as an ideal gas. And then we're going to assume that we have a closed system, which means that we use the Q minus W delta E, which becomes delta U if velocity and elevation are constant. And it also means that whatever was going into or out of my system and changing the energy inside, like like a mixture of gases leaving the system or so on, we have to model it another way. So we're modeling that with Q in and Q out. So if you remember from your notes, we have that the first process is isentropic compression. So again, you may follow this, okay? Isentropic compression, so that means that delta S is 0. And because everything or every single process is reversible, then that means that Q will be 0 as well, okay? Then we have Q minus W delta U. We did this in class. It's compression, so we have another negative, and that's missing a parenthesis there after the W. Apologize for that. I could just add it before I take a picture. I already said it, so I'm going to add it. And then that means that we have 0 plus W equal to U2 minus U1. And I want you guys to, should have said this before, I want you guys to look online on Canvas, additional notes and gas power cycles. I posted this, okay? And this handout, I'm starting with this side over here, the air standard, okay? Like the air standard assumptions that we made. And this is very helpful. Not saying that it's helpful because I made it. It's helpful for me too. Like when I'm solving the exams or recommended problems, I use this. So you might benefit from using that. So we can see the equations here because we have delta S and everything is reversible. That means that Q is 0. Sorry, because we have delta S equal to 0. That means that Q is equal to 0 for the first process. Because we have isentropic, there are certain equations that we can use, and you can see them on the handout and also on the notes, okay? So as I mentioned, if you don't want to watch this, you are bored already, or you feel it's unfair, I'm going to go over the handouts when we come back. But I'm going to do it quickly, okay? So how long has this been already? 8 minutes. Jeez. All right, then if you look at the handout, it says that VR2 over VR1 is V2 over V1, and then you see 1 divided by R. So that's a new thing. It's not on the notes yet. So that R, it's called a compression ratio, okay? So you can add that to the notes. Actually, when I send you my notes and I have a YouTube video, I understand that might be confusing for you when you're organizing your notes for exams. So maybe you can rewrite it on your notes. Just, pretend I'm writing it on the board. You write it on your notes, or you just print it out and you write anything else you want to write on it, okay? I don't want this to affect you in a negative way, but I understand that it might. Just let me know if I can help some other way, okay? That R is called compression ratio, and that is Vmax over Vmin, or maximum volume divided by minimum volume, okay? Now, then we have that W is U2 minus U1, and we determined how to do that in class, okay? So we move on to the next process. After I compress it, all right, then I'm going to heat it up, all right? And that is constant volume at the minimum volume, heat addition, instead of having combustion. So we have constant volume, as you see on the notes. That means that P over T is constant because we have an ideal gas. It's just how it is, okay? So I can't do that for every process. I'm doing that for 2 to 3 because it's constant volume. So that means I cannot say P1 over T1 is P2 over T2. I can't do that. I'm just doing that because it's constant volume. So here you see it's like a review of everything we've done. Okay, not everything, but everything for ideal gases and closed systems. So then we have again Q minus W delta U. You see that on the notes. W goes away because it's constant volume. Okay. Then Q is in, so it would be a positive sign. If we want to add another sign to it, so we just leave Q, U3 minus U2. And if you look at the handouts, right, then you can see it there. You have constant volume, so we have P over T constant, you have that work is 0, and you have Q is U3 minus U2. So I'm doing the air standard side, because the other side, cold air standard, if you look at it, it's constant specific heat. So we're going to leave that for later, okay? So the next thing that I did on my notes is start PV and TS diagrams. We haven't done many TS diagrams yet, I understand. So, you know, I want you, as I said, to either print out the notes, right, and write on it, or if you're more comfortable with it, pretend I'm just writing that, all right, and you are rewriting it on your notes, especially if you don't feel very comfortable with the material, okay? On the PV diagram, first we see 1 to 2. Let's just look at that one, just 1 to 2, okay? So you should have this. So 1 to 2, we have compression, so the volume is decreasing. So we see that. We see that V1 is greater than V2. Not only that, but V1 is Vmax, and V2 is V minimum. And you see that over there it says Vmax or Vmin, it's R. So that's the compression ratio. Compression ratio, okay? Now, you see that it's curved from 1 to 2. We've done a lot of straight lines in class. So you might think like, why are we doing a curve now? In addition to that, for a PV diagram, we know that for T constant, which is PV constant, you also have a line, not a line, you have a curve like that. This doesn't mean that this is PV constant. I want you to keep that in mind. It doesn't mean that T is constant because we have Q equal to 0, okay? Temperature is actually increasing, all right? This is just the way that it is when we set delta S equal to 0 for an ideal gas. If you guys remember, we have delta S, S2 naught minus S1 naught minus R natural log of P2 over P1, or yeah, P2 over P1 in this case. So if we set that equal to 0 and we want to plot what's happening to pressure versus volume as we have our work in, then we would have a curve when it's isentropic, okay? I won't ask you guys to prove it or show it, all right? That's just the way it is. So you can, I guess, you can do that on your own if you want to confirm that it's a curve, but we can no longer make it a straight line because of the relationship, delta S equal to 0, and of the properties, how they are changing in there. Delta S depends on the change in temperature and the change in pressure, and it also depends on change in volume, because this is affecting the other properties as well, okay? So it will be a curve. Then 2 to 3, we have constant volume and we have Q in, all right? And the pressure and the temperature, they will both increase. So 2 to 3 is a straight line up. Now if we look at TS, 1 to 2, straight line up because the temperature is increasing and it's isentropic as constant, so that's why it's a vertical line. But then 2 to 3, same thing, all right? We have a curve. 2 to 3, we have Q in as a constant volume. So if you want if we want to see what happens to delta S, we would use the same equation from before. Delta S, S2 naught minus S1 naught minus R natural log of P2 over P1. And we can determine that that is a curve, all right? It's a curve, the same thing. I won't ask you guys to prove that. But why do we know that it's moving to the right, okay? This 2 to 3 is where we have Q in. And we know that S gen is equal to 0 for all these processes. That means that delta S depends entirely on Q over T. So if Q is in, it's positive, which means that delta S is positive. It is not increasing due to irreversibilities. It would only increase due to heat transfer, and that's why it moves to the right. I don't know how you see this once I post it, but it's moving to the right, okay? And the curve, same thing, right? I'm not gonna ask you guys to prove that. So I'm almost done with the first 15 minutes, so I'm gonna stop and then do the next 15.